So we've covered mole-to-mole stoichiometry, mass-to-mole stoichiometry, and today we'll cover mass-to-mass stoichiometry. First question reads, how many grams of potassium chloride KCl produced if 25.0 grams of potassium chlorate KClO3 decompose? Okay, so let's think about a roadmap. We are starting outside of our mole box. Okay. With 25.0 grams of KClO3. KCl. So what we're going to do is we're going to convert, so we get into the club, mole to moles of KCl, right? Then from KCl, once we're at moles of KCl, now we can use our mole ratio. So we know that for every 2 moles of KClO3, there's 2 moles of KCl. So we can convert this to moles of KClO3. And then this says it doesn't want moles of KClO3. Oh, I'm sorry. So let me back up. It says 25.0 grams of potassium chloride. So this is KClO3. We're trying to figure out KCl, right? So this is KClO3. And this here would just be KCl. So we have moles of KCl. And then you get grams of KCl. Okay. All right, so let's start. So we have 25 point, I'm going to do this in individual steps. So 25.0 grams of KClO3. And I'm going to have to calculate the molar mass of KClO3, so potassium chlorate. Let's see, so we have 1 potassium. So 1 potassium is 39.10. Plus chlorine, which is 35.45, plus 3 oxygens is 122.55. All right, so now we're going to convert to moles. Now we get to be in the club. So 25 divided by 122.55. So this is the moles of KClO3. So now we have moles of KClO3. We can now convert to moles of KCl. Once you have moles, you get to use the molar ratio. Remember, it's called a molar ratio. So in order to use this molar ratio, you need to have moles. So there's 2 moles of KClO3 for every 2 moles of KCl. So this would be the same thing, right? But now, instead of moles of KClO3, you have moles of KCl. And then it wants grams of KCl. So we have moles of KCl. And so 1 mole of KCl, that's 39.1 plus 35.45 will equal 74.55 grams KCl. So times 0.2040. This gives us, we want 366, so 15.2 grams of KCl. All right, so you'll see how, in order, since we start with grams, we need to convert to moles so we can use the molar ratio to convert from KClO3 to KCl. Once we have moles of KCl, we can convert back to grams because we want grams of KCl. Okay? All right, so try the next one on your own, and I'll show you how to solve the next one. I'll just do the next one as one step. So I'm starting with 50 grams of nitrogen, N2, and I want grams of hydrogen. In order to change from nitrogen to hydrogen, though, I have to convert to moles since I need to use the molar ratio to go from N2 to H2. So that means I need to get into the club, the mole club. And so I'm starting with 50 grams of N2. I'm going to convert that to mole of N2 using the molar mass. Then I'm going to use molar ratio since I'm in the club to convert to mole of H2. and then to grams of H2. Okay? All right, so I start with 50 grams of nitrogen. I first convert it using molar mass. N2 is going to be 28.02 grams of N2, and 1 mole. This converts to 1 mole. Now, if you want to stop here and you want to solve, that's cool. So you get moles of N2. However, I'm going to keep on going, so I'm going to make this into one step. So then my next step is, once I have moles of N2, I'm going to convert that to moles of H2. So for every 1 mole of N2, I have 3 moles of H2. All right, so now if I cross cancel, I now have moles of H2, so I'm right here. I need grams of H2. So for every 1 mole of H2 is 2.02 grams of H2. My final units are giving grams. So 50 divided by 28.02 times 3 times 2.02 gives you, to 3 sig figs, gives you 10.8 grams of H2. Okay. All right. I have assigned some homework online that will be due on Monday.